tough. Okay, we're up and running. Good morning, everyone. Today we're going to talk about the rational root theorem. And our author in, what section is that? 4.4. In section 4.4 calls this the rational zero test. Rational root theorem is much more common, so just be advised it might go both directions. Okay, so this is a method to find roots of higher exponent polynomials. And again, we've talked about x squared is no problem. Use a quadratic formula. X cubed is a little bit harder. Oftentimes you can factor it. If you get past x to the third, and it's really hard to solve those without graphing. Okay? So an algebraic method, I would say. So, Luke read that mess, and eek. In the book, that thing is a mess. It talks about a sub n. It talks about a sub 0. Eek. Well, let's just see what an example looks like. Okay. Let's say we have f of x equals 3x to the fourth plus 13x cubed plus 15x squared minus 4 equals 0. Now, so we notice that this is a fourth degree polynomial with a positive leading coefficient. What else is noteworthy about this expression? What else is noteworthy about this? Cameron? It's fine. You're not wrong. Just what comes to your mind? There are some sign changes, Delaney. Okay. There's no linear term, no x to the first, and we will have to account for that later. Yeah, that's what I was looking for. No linear term is one where we've got to no linear term. And I'm going to say danger Will Robinson on that, okay? Make sure we deal with that. Okay, so this 3 is, I'll put it up here, a sub n that Luke read about, and negative 4 is a sub 0. Okay? So then it said if P over Q is a 0 of F, then P is a factor of the constant term a sub 0, and Q is a factor of the leading coefficient. Okay, so let's go a different color. So Q is a factor, and maybe I should say possible factor, but we'll show you that in a minute. Q is a factor, and P is a factor. P is a factor. Okay. So, that means that Q could be, what are the factors of 3? Factors of 3. Come on, this is not magic. No, factors, not multiples. 1 and 3. It's prime number. So it could be plus or minus. It could be negative as well. Plus or minus 1, plus or minus 3 are factors. And then P could be, well, P is a factor of negative 4, so what are possible factors of negative 4? Plus or minus 1. Somebody other than Sean, plus or minus 2. Plus or minus 4. Good. Now we're on the same page. So Q could be 1, negative 3, or 3. And P could be negative 1, positive 1, negative 1, positive 2, negative 4, positive 4. Okay? So far, so good. That means that P divided by Q could be what? P divided by Q. Maybe I should have written these in the other order. It's not hugely critical. Might be able to move them. P divided by Q could be, and there's a whole string of them, plus or minus 1 over 1, plus or minus, not 1 over 2, I don't think. No, I think you guys are getting it backwards. P over Q. 2 over 3, there you go. What else? Plus or minus 4 over 3. Plus or minus, somebody other than Cameron. Let's get involved. AJ, give me one. Yes, plus or minus 4 over 1. Plus or minus, John, you had one? 2 over 1, there you go. Do we have them all now? There should be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We're missing 1. Not 3 over 1. 1 over 3. Okay. Okay. I think we have them all. Okay, questions on that? Delaney? Está bien? Okay, good. If you have questions, ask, man. Now's the time. Okay, and you're going, where is he going with all this? Let's simplify these. This could be plus or minus 1. That one's the same. That one's the same. This could be plus or minus 4, plus or minus 2, and that one's the same. Okay, so where am I going with all this? Well, now we know that these are possible roots, okay? That means that these are possible roots. And that's big. I mean, we're somewhere where we were not a minute ago, okay? Before, we just had this quartic expression, right? And we didn't know at all what our possible roots, let alone our possible factors are. But now we have some possibilities. So, Anne-Marie, talk to me about daughters and coffee and lofts. And roots. If we know that we have this polynomial expression, and we know that we have these possible roots, what's a relatively fast way that we could check to see if these are actual roots? Oh, bless your heart. You said it with pain in your mouth, but it's okay. Synthetic division is probably good. You can use long division, but synthetic seems to be faster. Right, man. So now, remember when we said Danger Will Robinson up here? Now's the time we got to pay attention. So tell me what goes with my synthetic division. I'm going to go right there so we have room. So now I have 3. What next? 13, 15, 0 right there. Pull the Delaney right there with 0. -4. All right. Let's go. Well, let's go with an easy one. 1, right? Let's check 1. It's fast. It's quick. It's all right. We bring down our 3. We go 3 times 1 is 3. Don't forget, we're going to add these. We get 16. We go 16 times 1 is 16. We add them. What do we get? 31. We go times 1. Still 31. We add them. Still 31. We go times 1. Still 31. We add them. 27 remainder. What does that mean? What conclusion can we draw? Ow! What conclusion can we draw? Is that you, AJ? Luke? Conclusion? It's not a root. So, 1, I'm going to go in red. 1 is not a root. Hey, so what? Fall down 7 times, get up 8 times. Right? Big deal. Do it again. If you're crafty, you can just write, and you don't have to, but if you're crafty, you can just write this part. You can do it all again. Let's try to be crafty. Bring down my 3. -2 times 3, -6. Add them. 13 and -6, 7. Times -2, -14, 15 and -14, 1. Times -2 is -2. 0 plus -2, -2. Ooh, check it out. -2 times -2, 4. You see it coming? Huh? 0. So, yippee. How do you spell yippee? 2 E's? 2 is a root. That's right, John. Oh, wait. No, that's right. -2. You were right. My bad. You were right, and thank you. I need the wisdom of the crowd. -2 is a root. Okay. So we're making progress. Questions so far? Please, please, please ask questions.
So we just use a possible root, right?
Correct. We were going through our list of possible roots here.
So
And
we don't use like fractions.
well, you can, but think about what a fraction would look like in here. It'd be a mess. So use the low-hanging fruit, like 1s and -1s. Those are the first ones I always try, just because they're fast. Yeah, no, you can use fractions in here, but it's tedious. It's messy. Okay, so this means that we don't want to lose sight of what we're doing. What's the factor then? X plus 2 times, what's the other big factor? Think hard. No, you don't need to. Hang on. 3x to the what power? Cubed. We started with a quartic. So this means we take a linear times a cube. This is x to the first times an x cubed gives us our x to the fourth. So 3x cubed plus, Camille, what's the next part? No, it'd be right here. 7, what? Seven what? x squared, good, plus, who haven't I picked on yet? 1x minus 2. If you multiply those two together, you get equals, no, 3x to the fourth. Here's your 13, plus 13x cubed plus, ouch, why does it do that to me? Plus 15x squared minus 4. Oh, man. See, that's progress. I know that's painful. I know we've been into it 15 minutes. Man, painful. I get it. But we didn't have this before. We didn't know that x plus 2 is a factor of this. And we didn't know that 3x cubed plus 7x squared plus 1x minus 2 is a factor of that. Okay? To me, that's great. Javier, are you thrilled? Yeah, you look thrilled. No, that's progress. Now, what could we do to get this? Remember, our goal will be to get this guy, to get this cubic down to a quadratic. Once we get it down to a quadratic, we can use our good old quadratic formula. What could we do to get this down to a quadratic? Right, we can do it again. The Anne-Marie synthetic division again. Okay, give me another color yet again. We can go 3, 7, 1, negative 2. And I should write what I'm doing here for your notes. I'll say perform synthetic division again. AGAIN. Okay, well, we already know one of those roots, so let's just use it again. We have negative 2, yeah? Yeah. So we can just use it again. If it's a root one place, it's a root every place. So what does that come out to be? Bring down the 3. Negative 6. Atom 1. Negative 2. Atom negative 1. Let's double check. Let's keep going. Negative 1 times 2 is 2. Atom 0. Boom. So we know then that, yeah, thank you, Joel. Okay. No, ask the question if you have it. You see it? Okay. So now this is 3x squared plus 1x minus 1. Okay? We can set that equal to 0. Use your quadratic formula program. A equals 3, B equals 1, C equals negative 1, or factor it or whatever. Complete the square, whatever. Quadratic formula program is probably the fastest. Gives us what factors? Oh, well, I guess let's start with the roots. When you run the program, what do you get, Cameron? X equals 0.434, really? Or X. Will somebody check that? I thought this came out nice. Doesn't come out nice? Okay. X equals, what was your other one, Cameron? 0.767. Okay, check that now. So what did we get out of that? We got, well, probably. I'm curious. So what did we come out? We got negative 2. Graph that to check. What are the roots? Let's make sure we did it right. Is negative 2 a double? 0.434, negative 0.767. Check that out. When you graph it, what do you get? I'm going to pause. Cool. Thanks for listening. Hope this helps.